lecture. Okay, so welcome you all for our NCM subject lecture. And from last lecture, we have started the new topic that is average water jet machine. Okay, so remaining part of this lecture today I will cover. Okay, so in last lecture, already I have covered the working principle, then setup for this average water jet machine. Okay, and which are the different process parameters that point we were discussing. And that fishbone diagram or cause effect diagram, that part also already I have discussed. Okay, so quickly I will take the recap on the which are the process parameters. Okay, because these process parameters have the significant impact on the performance of our average water jet process. Okay, so for that purpose, I will just highlight this point once again. Okay, now these process parameters regarding this average water jet machine, it is categorized or I can say the grouped into the four groups. Okay, now the first group it is related to the hydraulic parameters. Okay, so before going to this point, just tell me whether my voice is audible.
Sir, your voice is audible, but it is low, sir.
It is low. Okay, one minute. I will just check the.
Now my voice is audible?
Yes, sir, yes, sir.
Yes, sir.
Now,
Yes, sir. Okay. Please pin at Mr. Digambar Kashid presentation because there are the two names. Okay. One from my mobile and one from my PC. From PC, I have shared my screen. Okay. So just pin there only. Whether my PPT is visible or not. Presentation. Hello. Abhinay. Whether my presentation is visible.
No, sir.
Hello. Sorry.
No.
No.
yes, sir. No.
Oh, 1 minute. Oh. 1 second, I will just share 1 minute. Now,
Yes, sir, yes. It is visible.
okay. Okay, I was talking about the process parameters. Last lecture already was started or already covered this point, but as this point is so important, so just quickly I will take the revision on that point and then we'll proceed for further remaining part of this abrasive water jet machining. Okay, now as this process parameters having the significant effect on the performance of the average water jet process, so that these process parameters I have grouped into the four categories or the group. The first group is hydraulic parameters. Okay, so these parameters include the water pressure, water pressure, then water flow rate, or I can say the water jet nozzle diameter also. Okay, these three parameters will come under this hydraulic parameters group. Okay, now about this, if you have to maintain a minimum critical value of water pressure. Okay, that means average velocity or kinetic velocity which is required for the cutting of the particular material, and that value you have to keep below which we have to keep the minimum value, that is critical value of water pressure. Okay, below which no significant machining would take place. Okay, and the flow rate, whatever the water flow rate is there, no, that is directly proportional to the square root of the water pressure and the square of the nozzle diameter. Okay, so these formulae already you learned in the subject of the fluid mechanics. Okay, and the what are the depth of cut will be there, no? So that will increase with the increase in water mass flow rate, with again decreasing slope toward the saturation point, because the last time we have seen that effect also with the help of the graph. Okay, and the depth of cut varies linearly with the, now this is the second point, depth of cut which is varies varies linearly with water jet nozzle diameter for a given water pressure, and the nozzle diameter normally it is the ranges from 0.075 to 0.635 mm. Okay, that is the range, standard range is given. And for this abrasive water jet machining, water is used as a profiling fluid. Okay, which enables the high abrasive flow rates. Okay, that flow rates it may be 0.1 to 5 kilogram per minute, and that to be achieved. And again, it makes it to it's possible to isolate abrasives uh, with a high pressure or high velocity up to 300 meter per second. Okay, so this is the revision. Now again, second group of the process parameter is the abrasive related process parameters. Okay, now in that, what are the type of abrasive particles we are using? That also parameters will affect the process performance of the abrasive water jet machine. Then size and shape of the abrasive particles, again that is important, and the mass flow rate of the abrasive jet. Okay, so these parameters also we need to consider. Okay, so already I have discussed about this, because here again once again I will tell the, we are using the uh, different abrasives. Okay, so that should be harder than the workpiece material, and different abrasive means what? Garnet, silica sand, silicon carbide, alumina, glass beads, or steel glyphs are the most commonly used abrasives for this abrasive water jet machining. Okay, and in that again, garnet is most effective. Okay, garnet is most effective, and silica sand is the cheaper but least effective. While if you take the silicon carbide, that is expensive, but it gives the effective penetration in the workpiece material. Okay, so the range of the particle size for optimum depth of the cut is only for the brittle material than that of the ductile material. Okay, and the commonly used abrasive size ranges from 100 to 150 glyphs. Glyphs means for grain size, and the optimum value of the mass flow rates that also increases. Okay, now the most important here, abrasive flow rate. Okay, abrasive flow rate, it is generally 0.002 to 0.08 kilogram per second. That we have to maintain the abrasive flow rate. And the types of the abrasives to be used is determined after knowing hardness of the workpiece only. Okay, if you know the hardness of the our workpiece material, they depend on that you can choose the abrasive particles. Okay, again I will take revision on the cutting parameters also. Now in that cutting parameters, our traverse or the feed rate will come, stand up distance will come, then number of passes, angle of impingement, then properties of material. So these parameters will come under this cutting parameters. Okay, so these are the process parameters. Okay, then the last one, the mixing parameter. Again, mixing parameter in that method of supplying abrasives. Okay, because we have seen the abrasive feeding system is there, that is the one of the component or element of the abrasive water jet system. Then at in which condition we are giving the abrasive particle, so that abrasive condition, that is also important parameter. And the mixing chamber dimensions, so these points we need, or these control parameters we need to consider, because these are the significant parameter which will affect significantly on the performance of the abrasive water jet machining process. Okay, so we have seen in the last lecture how it affect the process. Okay, in the terms of depth of cut, material removal rate. Okay, so this is about the process parameter. Now let us discuss the advantages of this abrasive water jet process. Now, first advantage of this process is that this technique is getting acceptable or acceptance as a standard tool. For what purpose? For cutting metal in a number of industries. Okay, so number of industries is what? Like aerospace industry, nuclear power plant, then oil industries, foundries, automotive industries, constructions, and glass industries also. Okay, so abrasive water jet machining process, it is accepted by many industries for the cutting purpose. Then this abrasive water jet cutting, you can employ or this process can be employed for decommissioning of nuclear facilities. Okay, because already in last lecture also I have given this example in the nuclear power plant for the purpose of the dismantling. For that purpose we can use the robot, and in that robot you can use this abrasive water jet cutting system. Okay, so for that purpose this abrasive water jet cutting we can employ for the decommissioning nuclear facilities. Then the third advantage is that this process is economical as compared to the conventional bulk material removal process. Okay, this is the general advantage. Now, what are the curve or the slot widths which are observed during this process, or if you use this process, and then as output we are getting the curve, and so curve width or the slot width observed is in the range of 0.75 to 2.25 mm. Okay, so up to this this much range we can achieve the curve width. Okay, then roughness of the cut surfaces varies with the machine depth and the abrasive water jet cutting parameters. Okay, so what are the roughness of the cut surfaces are there? No, so that will vary with the machine depth and the abrasive water jet cutting parameter. Okay, so this is again advantage, and the last advantage is that as here we are using the water, correct, as the carrier medium. So I can say this is a cold machining process. So thermal traces are not will not be witnessed in this machined surface. Okay, so thermal traces will not occur during this process because this is a cold machining process. Okay. Now let us discuss the last point, that is the applications of this process. Okay, applications of this process. Okay, so just I will take the feedback whether my voice is clear to everyone. Lecture चालू है, आवाज बंद कर. अभी नहीं. Yes. Okay.
Yes.
Now I will quickly go for the application. Okay.
Yes, sir.
The first application about this process is that this process has been employed to cut a wide a wide range of materials, including both metals as well as the non-metals. Now, in that again metals, our copper and its alloys, lead material, then tungsten carbide, aluminum. So this type, all the metals we can cut using this abrasive water jet cutting machine or process. And if you take the non-metals is what? Granite, graphite, silica, glass, acrylic material, then concrete. So for that non-metal metals, if you want to cut, then this process we can employ. Then for the cutting, the sandwich the honeycomb structural material. Okay, sandwich the honeycomb structural material. Okay, so for that purpose to cut or to machine this material, we can use this abrasive water jet machining. Now, where we get this type of material? Okay, this type of material we will get in the, or this material it is used for the aerospace industry. So For aerospace industries also, we can use this abrasive water jet machining or cutting process. Then slotting is the one of the common applications of this abrasive water jet cutting or the machining. Okay, for the slotting purpose, mostly this process is used. Then the edges of structural aluminum plates. Okay, also we can or also we can successfully cut. Okay, using this process we can cut edges of structural aluminum plate. Okay, and the last application is that for the various steels like stainless steel, uh, mild steel, then special alloy steel, to cutting these various steels in different shapes like plate, tube, corrugated structure, we can use this abrasive water jet cutting process. Okay, for various steels in different shapes like plate, tube, corrugated structure, we can use or employ abrasive water jet cutting process. Okay, understood? Understood? Okay, so this is
Yes, sir.
so this was about the our
Yes, sir.
third mechanical energy based process. Okay, now before going to our next or I will say the last process belongs to the second chapter of the mechanical energy based group. Quickly I will go through the difference, similarities and the difference between the water jet machining and abrasive water jet machining. Okay, in syllabus we don't have the this separate point abrasive jet, that differences and similarity, but we should know that after learning this all the kinds of processes, we should know the differences and the similarities between these processes. So quickly we'll start this process. Now, as we know that both water jet machining process as well as the abrasive water jet machining, both are mechanical energy based the non-traditional machining process, or I can say non-conventional machining process. Okay, and it's for these both processes it have the wide variety of the applications. Okay, in metallic industries, leather industries as well as the textile industry. Okay, now, before going to similar differences, quickly within 1 minute, I will just tell the working principle of water jet machining. Now, in this water jet machining, clean water, okay, clean water is pumped to a high pressure. Now, for the pumping of the clean water, we require the fluid supply as the reservoir. Then for pumping purpose, we require the pump, and to boost the pressure, we require this intensifier because we are increasing its a pressure, that is a high pressure up to 2500 to 4000 bar. Okay, so with the help of this intensifier, we can boost the pressure, and this up pressurize the water because after this controlling unit or hydraulic unit we are getting pressurize the water, correct, and that we have to deliver to the work surface in the form of jet. Here we are getting the jet and here is the workpiece. Okay, so to form this jet of water pressurized water, we require the nozzle, and normally we are using the sapphire material for manufacturing the nozzle. Okay, now this the nozzle, what is the role of this nozzle? Because this nozzle is convert the pressure energy of the pressurized water into kinetic energy. Okay, and this high velocity, that means the near about 1000 meter per second, this high velocity jet we are getting at the exit of the nozzle. Okay, and then this water jet will impinge or strike or hit the workpiece material. Okay, and so due to this high velocity water jet, it will erode. That means the erosion action will start at the top of this workpiece. Okay, and from that erosion, material removal happen. Okay. Now let us quickly go through this abrasive water jet machining process. Okay. Here also we use the high pressure water. Then in mixing chamber, we take the abrasive particle from this port, and then we'll get the abrasive water jet. Okay, here, and from this mixing, this is a nozzle, and from this mixing tube, we'll get the abrasive water jet. Okay, and then you can heat or strike or impinge this abrasive water jet onto the surface of the our workpiece, and then due to the again the impact of that high pressure abrasive water jet, their material removal happen in the due to the action of erosion. Okay, now come to the our point. Similarities between the this water jet machining process and abrasive water jet machining process. The first similarity is that pump and intensifier are required for the both processes. Okay, just we have seen pump and intensifier both are required for the both processes. Then water pressure remains more or less okay same okay same for the both the processes. Okay, water pressure remains more or less for the both the process. Then typically water pressure remains in between 2500 to 4000 bar for the both cases. So these are the similarity, and the last is the jet velocity when it comes out of the nozzle. Jet means what? In terms for the water jet machining, water jet will be there, and for abrasive water jet machining, abrasive water jet will be there. Okay, and so velocity for the both the cases, it will remains around 1000 meter per second. Okay, and for the both the cases, we require for both the cases we require catcher. Okay, to reduce the velocity of used jet. Okay, and the nozzle is designed in the both the processes for what purpose? To convert the pressure of the either water or water abrasive mixture into the kinetic energy. Okay, so these are the similarities. Now come to the differences. Again, here I have shown the two columns. In one column you will get the points regarding water jet machining, and in the second column you will get the points regarding the abrasive water jet machining. Okay, now the first difference is that in water jet machining, a high velocity jet of pure water, sometimes it mixed with the stabilizer. So high velocity jet of pure water is used for erosion or erode the material. Okay, this is about water jet machining. Now, in case of abrasive water jet machining, a high velocity jet of water and abrasive mixture is used to erode the workpiece material. Okay. Then, in case of water jet machining, material removal from the workpiece is takes place only due to the erosion action of water jet. Okay. Please listen carefully or just concentrate on the slide. Okay. In case of water jet machining, material removal will occur or will take place due to erosion action of the water jet. But in case of abrasive water jet machining, material removal takes place due to micro cutting action of the abrasives. Okay, here micro cutting action of the abrasive is the important for the removal of the material. Okay, here directly water is not participating in that water removal of the material. Okay, because in case of this abrasive water jet machining process, water is just a carrier medium. Okay, material removal will take place due to only micro cutting action of the abrasives, because abrasives are available in the form of small or in the fine grain or grit uh, form. Okay, Now, for water jet machining, no mixing chamber is desired as abrasives is not mixed with the water because here only pure water where is it, so mixing chamber is not required. But abrasive water jet machining, in that mixing chamber is required for mixing a abrasives with the pressurized water and also to maintain the predefined the mixing ratio. Okay, for that purpose we require mixing chamber for abrasive water jet machine. In case of water jet machining, a jet of water does not possess high power and thus it cannot be advantageously applied for cutting metals or like ceramic. Already, the limitations of this abrasive limitations of water jet machining already I have discussed during that point. Okay, so as the this jet of water does not possess high power, so we can't apply or we can't use for this process for the cutting of metal, metal, alloys and the ceramic. We can use for the only softer materials. Okay. Now, in case of water abrasive water jet machining, jet of abrasive water mixture possesses enough power to slice metal plates of thickness up to 10 mm. So, due to that disadvantage, we can employ this abrasive water jet process for the metal as well as the non-metal. Okay. Then, general application is that about the general point regarding water jet machining is that it is free from the risk of abrasive embedment. Embedment means what? Mixing the abrasive particles. Okay, or sticking the abrasive particles on the finished surface. Now, in the water jet machining, we are not using the abrasives, so there is no availability of the abrasive particles on the finished surface. So it is free from the risk. But in abrasive water jet machining, there we are using the abrasive particles. So this process is associated with the risk of abrasive embedment, particularly for the ductile work is material. Okay. After the finishing or the machining or the cutting the surface, there might be a layer of abrasive particles on the finished surface. Okay. Now the last one is that this water jet machining process, it is suitable for cutting softer metal like softer material means what? Wood, leather, polymer, and the food atoms. So you can use water jet machining for the slicing purpose. Okay. So if you want to cut the meat, then we can use this water jet machining process. Okay. If you just see search on Google or YouTube, you will get the applications. So okay, I have some videos that also I will show. Again, for the this water jet machining, we can use for the cleaning purpose. Okay, like our spray. Okay, and removing of the coating surface. Okay, so for that purpose we can use. Now, abrasive water jet machining we can use for the wide variety of the application. Just we have seen. Okay, start from the wood, polymer, then the metal cutting industries, non-metal. Okay. Also, we can use this water jet machining process. Just I have seen discussed that for the slicing food items like frozen meat, fish in the food industry. Now, in abrasive water jet machining process, there are abrasive particles. So this process is unhygienic for the application of food industry. So this is a disadvantage or limitation. I will not say the disadvantage, but the limitations of this abrasive water jet machining. Okay, and here in one slide, I have shown all the differences. Okay, if you want to write or if you want to take the screenshot, you can take, no problem. For writing, it may take the more minutes. So just take the screenshot. And also I'm going to give the study. Don't worry. Okay. Whether you understood similarities and the differences between the water jet musting and abrasive water jet musting? Say yes or no in chat box. I'm checking the chat box.
Yes, sir. Yes, sir.
Quickly I will take because here we have finished this method. Now I'm going to take new one. Just I will ask one. Vaibhav Bosle, will you please unmute yourself? Vaibhav Bosle, B13. Vaibhav, are you there? Aniket Bansode, B10. Aniket, you understood what I
Yes, sir.
have discussed today? Understood or not?
Yes, sir.
Okay.
Yes, sir. Understood.
Can you tell the application of abrasive water jet musting? One application where we can use this abrasive water jet musting. Can we use this abrasive water jet for the cutting the fish or the
Cutting particles at
आपण
high
यूज करू
velocity.
शकतो का? abrasive water jet musting आपण फूड इंडस्ट्री मध्ये यूज करू शकतो का? येस ऑर नो जस्ट.
Yes, sir.
कसं काय यूज करू शकतोय? त्याच्यात abrasive particles आहेत. Okay, abrasive particles means what? Al2O3, then silicate is there. Okay, glass bits are there. जर आपण ते कट करायचं ते
हा.
तर त्याचं ते abrasive particle त्या सरफेसवर चिटकतील नाही. मग ते हायजेनिक राहील का? Only water jet machining process we can use for the food industry because there we are not using the abrasives. Okay, but in abrasive machining we are using the abrasives. So this is unhygienic for application in the food industries. Okay. Okay, thank you. Please submit yourself. Now one more question I will just ask. Jaydev, B31, Jaydev.
Yes, sir.
Velocity of jet, water jet or the abrasive water jet किती असू शकते? velocity of jet किती असू शकते? In meter per second.
300 to 500.
300 to 500. Near about 900 or 1000. Velocity. चेक करा 300 to 500 आपण ऍव्हरेज जेट मस्टिंगला दिले का वॉटर जेट मस्टिंगला? ओके, थँक्यू. अनम्यूट करा, काय प्रॉब्लेम नाही. जयदेव, थँक्यू. नेक्स्ट एकतपुरे, प्रेरणा एकतपुरे, B02.
Yes, sir.
वॉटर जेट मशीनिंग प्रोसेस आपण नॉन मेटल कट करायला वापरू शकतो का किंवा हार्ड मटेरियल कट करायला?
Hard material. Yes, sir.
वॉटर जेट मशीनिंग आपण हार्ड मटेरियल कट करायला किंवा मशीन करायला वापरू शकतो का? येस ऑर नो?
What is it? No, sir.
नो ऑर येस?
No, sir.
ओके, फाय.
Hello, sir. Voice is
Huh?
breaking, sir. Voice is breaking, sir.
ओके ओके, म्यूट युअर सेल्फ, नो प्रॉब्लेम. ओके, एकतपुरे, म्यूट युअर सेल्फ, नो प्रॉब्लेम. Okay, so these are the references which are used for the my lecture. Okay. Okay, you can use VKGen book, Advanced Machining Process or Unconventional Machining Process by T. Jagdisha. Okay, then PK Mishra book. So all these books are available, physically available in our in institute library. Okay, and this VKGen subcopy of VKGen book, then Gary Bindick the book, that another book, and the one more textbook. So all this I have given the soft copy in the study material sheet. Okay, you can check. Now let us move for the new topic and the last topic, last process of the chapter number 1, chapter number 2. Okay, I hope everyone understood the all the processes whatever I have covered up till now. Today, now we'll start the new process or new topic, ultrasonic machining. Okay, again this ultrasonic machining is the mechanical energy based non-conventional or non-traditional machining or advanced machining process. Okay, here also we are using the mechanical energy, okay, for the machining, but that conversion of the mechanical energy will be there. Okay, so that we'll see. Now you can see the name is ultrasonic machining. So we should start with the what is mean by ultrasonic, correct? So I will start with that point. In the part one, we'll start with the what is mean by ultrasonic machining, then work introduction about the ultrasonic machining, working principle of ultrasonic machining. We'll see the block diagram of the working principle of the ultrasonic machining process. Okay. Now the question, basic question is that what is mean by ultrasonic? Okay. So first question is that what is ultrasonic? Now ultrasonic means what? Ultrasonic is a vibratory waves having frequency, vibratory waves having frequency greater than. Okay, I repeat. Ultrasonic means what? Ultrasonic is a vibratory wave having frequency greater than the upper limit of the human ear. Okay, upper limit of the human ear, and that is greater than or equal to 16 kilohertz, or I will say 1600 cycles per second. Okay, ultrasonic means what? Vibratory wave having frequency greater than the upper limit of our human ear. And now that upper limit of frequency means what? Greater than or equal to 16 kilohertz or 16,000 cycles per second. Okay. So if you get this much range of vibratory waves, so that time we can say it is a ultrasonic vibrations. Okay, ultrasonic vibratory waves. Okay, now there are two types of the waves. Okay, just I am taking the basic. Okay, because this is a physics. There are the two types of waves. One is the longitudinal waves, and second is the shear waves. Okay, one is the longitudinal waves and another is the shear waves. Now in case of ultrasonic machining, in case of our ultrasonic machining of USM, we normally use the ultrasonic longitudinal waves only. Okay, normally we are using this longitudinal waves only. Why? Because they are easily propagate. Sorry, they easily propagate in the solids, liquids as well as the gases. They easily propagate in the solid, liquid and gases. Okay, so due to this we are using the longitudinal waves in the ultrasonic machining. Okay, so this is just a general information. Now how that longitudinal waves we can form. Okay. Now I repeat, our topic is ultrasonic machining. So for cutting or the making the drill or the just of the subwork, we require or we are using ultrasonic waves. Okay, ultrasonic waves means what? Vibrations. Okay, now to generate or to form that vibration, vibration means what? Again, I will take the specifically longitudinal waves. So to generate this longitudinal waves, we require the one element that is called the longitudinal transducer. Okay, so for that purpose, I have shown this. So longitudinal magnetostriction. Okay, now again question arises: what is this longitudinal magnetostriction? Okay, now just see, if you use ferromagnetic metal, okay, if you use ferromagnetic metal, okay, and that this ferromagnetic metal, if you place in continuously changing magnetic field, ferromagnetic metal is placed in continuously changing magnetic field, then what will happen? Okay, so that basic question arises. So it, if you use this ferromagnetic metal or if you place in continuous changing magnetic field, then it results in changing in length of the transducer. Okay, so due to that we are using magnetostriction type transducer. Magnetostriction type transducer. Okay, in detail I am going to discuss this transducer in the next slide. Okay, just I am taking the basic. Okay, so magnetostriction type transducer is used for the ultrasonic machining. Okay, for generation of the longitudinal waves. And they are now what the in magnetostriction type transducer, what are the elements of the metal? So in this magnetostriction type transducer, this is normally made up of the nickel permeable alloy, permeable alloy. Then now again that in nickel permeable alloy there is a 40%, 45% nickel will be there and 55% iron will be there. And the second metal for this making of the transducer is the permanganate. Okay, permanganate. In now this metal is consists of 49% cobalt, 49% iron, and 2% vanadium. Okay, so this point is additional for our subject, because this is a metallurgy part. Okay, so magnetostriction type transducer is made up of the two types of metal. One is the nickel permeable alloy and the second is permanganate. Okay, and these transducers are made up of sheets. Okay, because okay, these types of the transducers are made up of laminated sheets, because there are the certain reasons like sheet metal reduce the ED current losses, and that is why transducers are made up of the laminated sheets. Okay, what is the role of longitudinal magnetostriction type transducer? Just generate the longitudinal vibrations or longitudinal waves. Okay, so for that purpose we require the this transducer. Okay, and that vibratory motion will be there. No, so due to that our machining action will happen, that we will discuss here. Now how that cutting action will happen or that machining action will happen due to this ultrasonic machining, that will okay. Now before that I will show you. Here is the transducer. Okay, and due to that we'll get the longitudinal vibrations, that is the ultrasonic vibrations. Okay, and that ultrasonic vibrations we have to give to the our workpiece. Okay, with the help of the abrasive slurry. Okay. Now, on the top surface of workpiece, we have to flow the abrasive slurry. Yeah? Abrasive slurry. Now, to get the momentum or hit the abrasive slurry, we require the vibration, and that vibrations are the ultrasonic vibration, and that vibration we have to take from the transducer. Okay. Now you understood what is the role of our transducer. Okay. Now here I have shown the block diagram of working of ultrasonic machining system. Okay. Now we'll start with the this point, AC power supply. Now, if you talk about the ultrasonic transducer, it would convert appropriate. That ultrasonic transducer converts appropriate form of energy into ultrasonic waves. Okay, because transducer it will consume the electrical energy. Okay, and then now electrical energy is on AC power supply, and this transducer it will convert into the ultrasonic waves. Okay, and normally in ultrasonic machine, electrical energy is converted to the mechanical energy with high frequency of vibration. Okay, now you understood what is role of mechanical energy. Now, in this block diagram, I have shown the AC power supply because we need the electrical energy, and that electrical energy we need to convert into the mechanical energy, means or the ultrasonic vibrations with the help of the transducer. Okay. Now, in the block diagram, I have shown that AC power supply it is connected to the ultrasonic wave generator. Okay, so this is one element, and then ultrasonic wave generator is connected to this ultrasonic transducer, and then ultrasonic transducer is connected to the tool connector. Okay, okay. Now, what is the role of this tool connector? Just to hold the tool. Okay, to hold the tool. A tool means what? This is that is one type of the horn or the tool where from where we are going to transfer the vibrations to the our abrasive slurry. Okay, so the tool holder, tool connector is required to hold the tool. Okay, then we have the now the what are the ultrasonic transducer produces the ultrasonic waves now. It is going to transfer to this tool, okay, through this tool connector, and due to that we'll get the vibrations, okay, at or the tool will vibrate with high frequency, means what, with ultrasonic frequency, and between the vibrating this tool and this workpiece there is a slurry. Okay, there is a slurry which consists of liquid as well as the abrasive particles. Okay, there is a slurry which consists of liquid as well as the abrasive particles. Okay, and this abrasive particles, or I will say the slurry or that abrasive particle, when they will hit by means of this tool, then they will move toward the workpiece. Okay, they will move toward the workpiece. Okay, and the large number of abrasive particles with their larger or high velocity, I will say the high kinetic energy, it will collide with this workpiece surface. Okay, and due to the kinetic energy of that high kinetic energy of that abrasive particles or abrasive slurry. Okay, because we are getting the vibrations from the transducer. Okay, continuously vibrating tool, it will transmit that vibration to the abrasive slurry. Okay, because abrasive slurry is present in between tool and the workpiece, and due to that hitting of the tool, means of vibrations of the tool, kinetic energy, high kinetic energy of the abrasive it will convert or it will hit the workpiece. So while hitting the abrasive particles on to the workpiece, that hammering action will take place, and due to that hammering, erosion will start. Okay, so erosion will start means what? Thousands of small craters will be formed on the top surface of the workpiece. Crater means what? Fine particles which are created on the top surface of workpiece. Okay, crater will form means what? There metal removal will take place. Okay, and due to that continuously hammering action, erosion will take place, and at last we'll get the finished component over there. Okay, finished components what? Machined components. Okay, so I repeat, due to the hammering, or I will say that due to the high kinetic energy or high velocity of the abrasive particles, it will that abrasive particles will collide with the workpiece surface, and as a result, hammering action will take place, and that abrasive slurry particles, they will erode the metal from the workpiece by creating thousands of very fine craters on the workpiece, and then we'll get, or as a result we'll get the finished machined component. Okay, understood? Understood? The first concept
Yes,
here,
sir.
you
Yes, sir.
why we need the transducer and why we are calling it as ultrasonic machining, because here we are using the ultrasonic vibrations. Okay, or I will say the longitudinal waves. Longitudinal is the our ultrasonic vibrations, because having the high frequency. Okay, near about, or I will say the equal to or more than 6 So to create that high vibrations, where the one element it is called transducer, and that transducer normally we're using the magnetostriction type transducer. Okay, magnetostriction type transducer. Okay, to generate the longitudinal waves. Okay, and to uh, transfer that ultrasonic waves from transducer to workpiece, we need a tool, and to connect that to the tool connector. Okay, again to transfer the ultrasonic from tool to workpiece, as a medium we are using the abrasive slurry. Slurry is what? Abrasive particles. Okay, and then due to a high velocity of the abrasive particles. Now, with high velocity, due to the continuous vibrations, ultrasonic vibrations, we'll get the high velocity of the abrasive particles, and it will hit the workpiece. Okay, and due to that, hammering, erosion will, so there will get thousands of craters. That means the fine particles. Okay, and continuously this process will take place, and we'll get the finish the product or finish the component. That means the action, machining action, machine the component will get. Okay, understood? So for clearly understood, understand purpose, I will run this block diagram. Okay, now same point I will explain you with the help of this diagram. Okay, now see, you can see here, this is a schematic diagram of the abrasive, sorry, schematic diagram of ultrasonic machining. Now there is a transducer. Okay, this is a transducer. You can use magnetostrictive type transducer. Okay, okay, and this is a transducer winding is there. and this is a connector, tool connector. Okay, and this tool connector will move up and down. Okay, this tool connector will move up and down. That means the longitudinally. Okay, with a high frequency, means what? Ultrasonic frequency, because we are getting that ultrasonic frequency from this transducer. Okay, then there is a nozzle. Here you can see this is a nozzle, okay, which will supply abrasive slurry. Abrasive slurry means what? Just a mixing of liquid plus abrasive particle. Now this abrasive slurry you have to give to in between tool. This is a tool and this is a work. Okay, then you can see this. I have shown red. So here it's this red colors in large view. Here I have shown. Okay, slurry is there. Slurry means what? It consists of liquid plus abrasive particle, and you can see tool is there. This is a tool. White part means a tool, and this shaded part is there. Work is there. Workpiece, and in between this we have given the slurry. Okay. Now, during this process, overcut is created. Overcut means what? That cutting action. Okay. Or extra part which is going to cut. Okay. Because vibrations will be there, no. And this overcut is created through the this slurry, and so due to this overcut, more metal will be removed. Okay, and this now overcut means what? This is just a gap between the tool surface and the side surface of the. Here you can see side surface of the our workpiece. Okay, now okay, see, come to this diagram. Okay, now due to the this longitudinal vibrations or longitudinal waves of the transducer, it is going to transfer to this tool connector to the tool. Okay, so we'll get the ultrasonic vibrations. Okay, and then this tool will vibrate in longitudinal direction, and that vibration is going to transfer to the abrasive slurry. Due to that vibration, high velocity or high kinetic energy will get to the abrasive particles, and due to high velocity, heating will take place. Okay, at the top surface of the workpiece. Okay, and due to that, erosion action will take place, and it will erode the material or machine the workpiece. Okay, and you can see how the small craters are formed here. Okay, small craters here. Now, but here what happened? Now, for example, I will tell if you want to drill after the drill, you have to drill a hole having the diameter 10 mm. Okay, आता 10 mm चं ड्रिल करायचंय, पण ह्या हाय अल्ट्रासोनिक व्हायब्रेशन मुळे काय होणार, हे टूल जे आहे ना त्यामुळे काय ओव्हर कटिंग होणार. म्हणजे काय 10 mm च्या जागी तुमचं 11 mm किंवा 10.1 mm चं ड्रिल पडू शकतं. ओके, सो दॅट मोर दॅन 10 mm जे तुमचं मटेरियल रिमूव्ह झालंय ना त्याला म्हणायचं ओव्हरकट. ओके, त्याला म्हणायचं ओव्हरकट. सो बाय कन्सिडरिंग ओव्हरकट, नॉर्मली दॅट टूल डायमेन्शन्स आर गिवन. ओके, म्हणजे टूलच देताना काय करा, आपल्याला 10 mm चं होल पाडायचंय तर 10 mm चं टूल वापरत नाहीत नॉर्मली, तिथं 9.9 mm वापरणार, कारण की आपल्याला माहित आहे की 1 mm काय 0.1 mm ते ओव्हरकट असणार आहे. मग जर मी 9.9 mm च जर टूल वापरलं, आता इथं वन्स अगेन आय विल रिपीट this ultrasonic machining is a non-traditional machining, and here we are not using physical tool. ओके, इथं डायरेक्ट कॉन्टॅक्ट येत नाही टूलचा आणि तुमच्या वर्कपीस, बिकॉज देर इज अ वन medium that is called the abrasive slurry. So tool we can take as a 9.9 mm. Okay, so whatever you want tool, no, so it's a dimensions normally we are giving by considering the overcut. And आता ड्रिल मला कसं पाडायचंय, फॉर एक्झाम्पल रेक्टँगल शेपचं पाडायचंय किंवा सर्क्युलर, तर कुणा पाडायचं तर वर्कपीस, तर त्याचा शेप पहिल्यांदा आपण टूलवर देतो. ओके, त्याचा शेप आपण नॉर्मली टूलला देतो. आपण म्हणू शकतो की टूल इज द जस्ट अ रेप्लिका ऑफ what you shape you want to produce on the workpiece. Okay, टूलचा शेप कसा असणार आहे, जो शेप आपल्याला वर्कपीसवर क्रिएट करायचा आहे और मशीन करायचा आहे, तो शेप नॉर्मली आपण टूलला देतो. ओके, फॉर एक्झाम्पल मला सर्क्युलर होल ड्रिल करायचंय आणि रेक्टँग्युलर तुम्ही शेप दिला तर ते शेप येणार आहे का तुम्हाला त्या वर्कपीसवर? नाही. ओके, सो दिस पॉइंट यू हॅव टू कन्सिडर. Here, take a note of that. Overcutting will be happen. Okay, now that overcutting, it is not with a high dimension. Okay, that is in micro dimension. Okay, so that point normally designer are considering while giving dimension to the tool. Okay, now you understood the working of this. Understood or not? Say yes or no.
Yes, sir.
Okay. Now once again, we'll continue this working principle of ultrasonic. Now, as I have discussed that in this process, electrical energy, okay, of high frequency is going to convert into mechanical vibrations. Okay, through transducer element. Okay, electrical energy of high frequency is going to convert into the mechanical vibration. Now you understood, mechanical energy based process is the this ultrasonic busting process is the mechanical energy based process, because here we are using the mechanical vibration, but these mechanical vibrations are created using the electric energy. Okay, and to convert that electric energy into the mechanical vibration, we are using the transducer. Okay, and these mechanical vibrations are transmitted to the abrasive particles in the slurry. Okay, via energy focusing devices. Energy focusing devices means what? Our tool connector with the tool holder, or that tool connector means what? You can say tool holder. Okay, it is also called horn, as well as it is you can say tool assembly also called, and concentrator also called, because that tool connector, it is a energy focusing device, so it is called horn or tool assembly or the concentrator. Okay, now again, if you talk about transducer in detail, there are two types of transducer normally used. One is the already I discussed the magneto-strictive type transducer, and second is the piezoelectric transducer. Okay, you can use this type of transducer, magneto-strictive transducer and piezoelectric transducer. Okay, now if you talk about the magneto-strictive type of transducer, it has the certain characteristics. That means that it gives low efficiency, but it can produce the high power. Okay. On the other hand, piezoelectric type of transducer is there. It has the higher energy efficiency, and it does not require any cooling. Okay, so there is no heating damage. But the problem is with this piezoelectric is that its power capacity is low. So most of times magneto-strictive type transducer is used. Okay, okay, we should not go in the detail of we should not go in physics of this transducer. Okay, So this is about the working principle of ultrasonic machining. Now, before going to setup, just quickly we'll take the revision of this. Okay. Now, Atharva Kulkarni, please unmute yourself. Atharva Kulkarni. Atharva Kulkarni. Okay. ज्ञानेश्वर शितोळे. ज्ञानेश्वर शितोळे. ज्ञानेश्वर. Okay. Why this ultrasonic machining process belongs to mechanical energy non-traditional machining process? Why? Why ultrasonic machining is belongs to or grouped in this mechanical based processes? मी ह्या अल्ट्रासोनिक मशीनिंग प्रोसेसला इलेक्ट्रिकल एनर्जी बेस्ड प्रोसेस का म्हणू शकत नाही? नाही का? ओके. नेक्स्ट सचिन केंगार. सचिन केंगार. आहे का नाही? नाही. ओके. नेक्स्ट आदित्य मोटेवार. आदित्य मोटेवार. प्रणय डिसले.
येस सर.
ओके. हा, तुम्ही सांगा, आपण याला अल्ट्रासोनिक मशीनिंग प्रोसेस ही आपण मेकॅनिकल बेस्ड प्रोसेस का म्हणतो?
सर दोन कारण आहेत. ती पहिले तर अल्ट्रासोनिक व्ह्यूज क्रिएट होत्या त्या आणि इरोजन ऍक्शन न मटेरियल रिमूव्ह होते.
मग इथं मेकॅनिकल एनर्जी कुठे वापरतो आपण?
मेकॅनिकल एनर्जी म्हणजे ट्रान्सड्युसर कन्वर्ट करत नाही इलेक्ट्रिकल एनर्जीचा मेकॅनिकल मध्ये व्हेव्स क्रिएट करून, आणि त्यानुसार व्हायब्रेशन क्रिएट होत नाही ते.
हा, मग व्हायब्रेशन म्हणजे काय? मेकॅनिकल व्हायब्रेशन. सो हियर मेकॅनिकल एनर्जी एनर्जी is used in the form of mechanical vibration. Correct. Thank you. Now one more question to Pranay. ट्रान्सड्युसरचा रोल काय महत्वाचा? ट्रान्सड्युसर का वापरतो आपण? ट्रान्सड्युसर
कुठला सर? ट्रान्सड्युसर इलेक्ट्रिकल एनर्जीचं कन्व्हर्जन अल्ट्रासोनिक व्ह्यूज क्रिएट करण्यासाठी करतो आपण.
करेक्ट. ओके. नाउ नेक्स्ट क्वेश्चन. थँक्यू प्रणय. मी अनम्यूट करा, सॉरी म्यूट करा, काय प्रॉब्लेम नाही. आता नेक्स्ट, अरे दुसरा कोण आहे? हा, नानासाहेब शिंदे. नानासाहेब शिंदे, प्लीज अनम्यूट युअर सेल्फ. विश्वजित शिंदे. विश्वजित शिंदे. दीपक शिंदे.
येस सर.
दीपक, इथं ऍब्रेजिव्ह स्लरी का वापरतो आपण? ऍब्रेजिव्ह स्लरी का वापरतो? ऍब्रेजिव्ह स्लरी आपण का वापरायचे? ऍब्रेजिव्ह स्लरी कळालं की लिक्विड प्लस ऍब्रेजिव्ह पार्टिकल्स आहे. आता जसं डिस्लेने सांगितलं की आपल्याला ट्रान्सड्युसर थ्रू आपल्याला अल्ट्रासोनिक व्हायब्रेशन भेटणार आहेत लॉन्जिट्युडिनल वेव्हजने. ओके. ते आपण टूल कनेक्टर जे आहे किंवा हॉर्न म्हणतो आपण, बिकॉज इट इज फोकसिंग डिव्हाइस. त्यांना आपण ट्रान्सफर करतोय व्हायब्रेशन. करेक्ट. टूलचं व्हायब्रेशन आपल्याला कोणाला द्यायचं आहे? वर्क पीसला. पण इथं नॉन ट्रान्झिशन नसते, म्हणजे टूल डायरेक्टली आपण कॉन्टॅक्ट मध्ये आणू शकत नाही. मग ते दोघांचं व्हायब्रेशन जे आहे, सॉरी व्हायब्रेशन जे आहेत ते आपल्याला कुणाला द्यायचं, वर्क पीस मटेरियलला. कशासाठी? तर मशीन करायचं. तर आपण ऍब्रेसिव्ह पार्टिकल वापरतोय आणि ते ऍब्रेसिव्ह स्लरी काय करणार आहे, तर व्हायब्रेशन काय होणार, व्हायब्रेट होणार विथ हाय वेलॉसिटी. आणि हाय वेलॉसिटी व्हायब्रेट होतं म्हणजे काय, ते हिट करणार कुणाला, वर्क पीसला. हिट म्हणजे काय, याच्या वर्क पीसला स्ट्राईक होणार. आणि ते कंटिन्युअसली हाय वेलॉसिटी म्हणजे काय, हाय कायनेटिक एनर्जी. त्यामुळे ते हॅम्परिंग कोणा होणार आहे, तर वर्क पीसवर. आणि हॅम्परिंग वर्क पीसवर झाल्यामुळे काय होणार आहे, तिथं क्रॅकर तयार होणार. म्हणजे काय, वर्क मटेरियल रिमूव्ह होणार आहे आणि आपल्याला पाहिजे तो शेप होणार. कळालं?
येस सर.
ओके, म्यूट करा. थँक्यू. नाव मी जे आता स्क्रीनवर एक व्हिडिओ दाखवतोय ते सगळ्यांना दिसतंय का बाबा? आवाज येतोय का? आय थिंक नो. आवाज येत नाही ना? आवाज येतोय का? एक कोणतं सांगा, येस नो.
हो सर, नो.
नाही सर,
नो.
आवाज येत
आवाज
नाही.
येत नाही ना? 1 मिनिट. आवाज कसा केला?
आता पण येत नाही ना?
आता पण येत नाही ना?
नाही सर येत.
ओके.
ओके. दोन मिनिटात फक्त आहे. पहिल्यांदा वाईस दिले. वाईस म्हणजे काय, जस्ट आपल्या वर्क पीस फिक्स करण्यासाठी वाईस आहे, म्हणजे फिक्सर म्हणू शकता. त्याच्यावर आपला वर्क पीस आहे बघा, ब्रेटल मटेरियलचा आहे. आता तुम्ही वर बघू शकता की सिग्नल जनरेटर आला. ओके, सिग्नल जनरेटर पॉवर म्हणजे एसीचा पॉवर सप्लाय करायचा ना, म्हणून ते पॉवर अँप्लिफायर सिग्नल जनरेटर यूज. देन तुम्ही बघू शकता पोपटी कलरचा आहे तो आपला मॅग्नेटोस्ट्रिक्टिव्ह ट्रान्सड्युसर आहे. ओके, फॉर व्हॉट पर्पज इट इज यूज, टू प्रोड्यूस ए अल्ट्रासोनिक व्हायब्रेशन. ओके, देन ओके, नाव यू कॅन सी हिअर. इथे तुम्हाला हे दिसतंय बघा, हॉर्न ऑर कॉन्सन्ट्रेटर. हे हॉर्न म्हणजे काय, तर तुमचं ते मला कनेक्टर, टूल कनेक्टर म्हणजे म्हणतो ना, ते हॉर्न कॉन्सन्ट्रेटर आहे. ओके, तर ते कशासाठी वापरतो, सॉरी, आता हॉर्न कशासाठी वापरतो किंवा कॉन्सन्ट्रेटर, आपल्याला व्हायब्रेशन अँप्लिफाईज करायचे. ओके, सो दॅट अँप्लिफिकेशन मे बी इफ यू वॉन्ट टू गो फॉर मोर दॅन 16 kilohertz, then you can use horn or concentrator. Okay, for amplifying the vibrations. Okay, मग पुन्हा ते हॉर्नला आपण टूल कनेक्ट करू शकता, म्हणून ते टूल पण कनेक्ट केलेलं आहे. दिसतंय? नाउ दिस टूल विल व्हायब्रेट विथ अल्ट्रासोनिक फ्रिक्वेन्सी. बघू शकता. आता इथे दिसतंय का, नोझल आहे बघा. नोझल कशासाठी वापरतोय, तर ऍब्रेसिव्ह स्लरी देण्यासाठी. त्यात लिक्विड असणार आहे आणि प्लस ऍब्रेसिव्ह पार्टिकल. मग ऍब्रेसिव्ह पार्टिकल तुम्ही सिलिकॉन कार्बाइड वापरा, Al2O3 वापरा किंवा बोरॉन वापरा, नो प्रॉब्लेम. ओके, सो दॅट अगेन इन दिस वे आर गोइंग टू सी. हे आहे. Now you can see that longitudinal vibrations which is produced by the transducer it will transport to the tool, and through that tool abrasive slurry, okay, and then that abrasive particles will hit the workpiece, and their craters will be formed on this workpiece. Okay. ते कंटिन्युअसली व्हायब्रेट होणार आहे. ओके. तुम्हाला एक जनरल एक्झाम्पल देतो. आपल्याकडे नॉर्मल आहे ना, विहीर खोदताना किंवा एखादं मोठं बांधकाम करा अगोदर पाया खणतो माहिती का, कधी कधी आहे ना मोठी दगड लागतात. दगड मग काय करतो आपण फोडायसाठी नॉर्मली एक व्हायब्रेटर वापरते माहिती का. ओके, त्याला एक पुढे बार असतो. ओके, पार म्हणतो त्याला आपण, आणि ते कंटिन्युअसली व्हायब्रेशन देतो. आणि ते कंटिन्युअसली इम्पॅक्ट केल्यामुळं असं होतं की थोड्या वेळानंतर ते जे मोठा दगड वगैरे असतो ते ब्रेक होतो बा किंवा फुटतो बाजूला. सेम प्रिन्सिपल. ओके. अंडरस्टूड. Now here we'll see the practical application. This is ultrasonic one machining, advanced machining. See how the machining takes place. Here they have shown the application of ultrasonic. Now, if you want to manufacture knee joint, no, in the medical field, in that application, I'm going to discuss, no problem. See, machining of hard metal, then bone plate, we can go for the through this. Now this is the advanced machining. Ultrasonic technology they have used. Now see, can the vibrator generator they have shown. आता तुम्ही म्हणत असाल की इथं abrasive slurry कुठं आहे. ओके, आता त्या बरोबर त्या नोझल थ्रूच येतो. आता इथं बघू शकता जास्त अडवान्स. आय विल शो वन मोर. हा हा, करेक्ट. Now I think it is now clearly visible to you all, and you will get the concept. सगळ्यांना व्हिडिओ दिसतोय का व्यवस्थित?
येस सर.
Yes, sir.
ऍक्च्युअली त्या व्हिडिओवर आवाज पण आहे, पण आता आपल्या पिक्सल ही ना see how that continuously hampering is there. That means the ultrasonic vibrations. Okay, normally this is you can see this type of setup is there. Okay, आपल्याकडे अल्ट्रासोनिक मशीनिंग नाही. ते तुम्ही जर WC ला किंवा COP ला गेला तर अल्ट्रासोनिक मशीनिंग भेटून जाईल बघायला ऍट ऍक्च्युअल. ओके, सो जर कुणाला मिनी अल्ट्रासोनिक मशीनिंग किंवा मायक्रो मशीनिंग, अल्ट्रासोनिक मायक्रो मशीनिंग जर बनवायचं असेल तर तुम्ही बीएचा प्रोजेक्ट म्हणून करू शकता. आता आपल्या सिलेबस मध्ये मी फक्त जनरल पार्ट जे गरजेचं आहे ते मी सगळे एलिमेंट तुम्हाला एक्सप्लेन करतोय. पण त्यात थोडं ऑटोमेशन जर तुम्हाला करायचं अदर पार्ट यू कॅन use, no problem. Okay. AC power supply under the in that element everything will come. Amplifier and that other part. For pumping of the that average slurry, they have used pump. Then that average, see how they have supplied. And the vibration of tool and the average slurry and remove the material in the form of small grains. Grains you can call or the glit or cracker you can call. No? See how the machine surface is there. सगळ्यांना समजलंय का बाबा? वर्किंग प्रिन्सिपल ऑफ अल्ट्रासोनिक मस्टिंग सगळ्यांना समजलंय का?
Yes, sir.
Okay. Now we'll go. Okay. I think I have not shown you a video regarding water jet machine, abrasive water jet. Now it is available with me. So before going to set up of this ultrasonic, I will show that video. But that is remaining. One by one, Mr. Water jet cutting. हे काय these are advanced machinery, no problem. Now to give that proper desired shape, okay, we require CAM, means what the CAD CAM, computer aided manufacturing, coding type. Now here I am showing advanced machine. See, आपल्याला हे शेप आपल्या वर्कपीस वर पाहिजे. इम्पेलर म्हणू शकता ह्याला तुम्ही. This is workpiece. Now they have given the original to the tool. See. फक्त high pressure, high velocity water, pressurized water they have used. And now see here, average also there. Now water, only water. See. From that workpiece plate, finished the component we got like this. Okay. Here in 2D cutting and 3D cutting, it is given in one machine only. If you want to go for the 2D, then also. अजून एक component बघा. Okay. So this type of small component also we can manufacture using our advanced machine process. Now we'll see the abrasive cutting. This is the abrasive cutting application, and that is a nozzle. From here you will get the high pressure here. Here that coolant is there with that. Or you can, I think, it's abrasive water jet cutting. Okay. One more I will. Again, this is the average jet machine. Small, I think. This is one project or manufactured by simple average jet machine. No, they have given the average particles. See. This is a simple setup. We can develop such a setup in our college also. This is a nozzle. See, nozzle, and here that uh, gap is there. Nozzle tip distance or SOD. This is that plate, nozzle workpiece plate. Okay, see how also that machine part means the drill is there. Then we'll see the abrasive water jet cutting. This is the application of abrasive water jet cutting. They are ingrowing the that name. Loan. This workpiece, a circular workpiece. So this is machined part, finished part. Different types of or variety of machines are available in the manufacture in market. Okay, with automation and okay. See, cutting action is going on. Cutting. Uh,
हॅलो सर.
Hi, 1 minute. Now another one. Cutting of rock with water and abrasive. Rock. Actually, I was writing roll number. Again, we have the another one. I think I have shown, no?
Yes, sir.
बघितले आपण. Now, cutting of pipe using water jet. See, this is one machine. Okay, Simon, just I will ask. ओंकार काळे. ओंकार काळे. ओंकार काळे. रोल नंबर किती दिलाय तुम्हाला बा? Then समर्थ माने देशमुख. रोल नंबर. सुमित पटवारी. रोल नंबर किती दिलाय?
Not given.
Not given. Okay. Okay. Aman Mulani. Please tell me your roll number. Aman Mulani.
Hello. Hello, sir.
Roll number. Roll number.
Sir, not given.
Aman. Not given.
Hello. Sir.
Okay, okay, okay. Then Aniket Sarvay.
TB 43, sir.
किती?
43.
B43.
हाँ TB 43.
ओके. अथर्व कुलकर्णी. अथर्व. रोल नंबर सांगा.
Sir, B23. B23.
ओके ओके नोटेड. शितोळे. ज्ञानेश्वर शितोळे.
B49.
B49.
Yes, sir.
Then घनश्याम चितरी.
A20. A20.
ओके नोटेड. नोटेड. हर्षदा पाटील. हर्षदा पाटील.
रोल नंबर is
Roll
not
number?
given, sir.
Okay, no roll. Okay, those who don't have a roll number, please contact to AS in the sir or CC Jadhav sir. Both are CCs. Okay. समर्थ माने देशमुख. समर्थ रोल नंबर सांगा. समर्थ नाही का?
Hello, sir. Hello.
हा.
Can you please take my roll number
Aman,
29,
बोला.
sir? 29, sir. B29.
अमन मुलानी. अमन मुलानी नो.
Yes, sir. Yes, sir. B29.
B29.
Yes, sir.
दिलाय
Yes.
का रोल नंबर तुम्हाला?
हाँ सर हाँ येस सर बघितलं मी.
B29. ओके.
हाँ येस सर.
ओके ओके थँक्यू. ओके. So student has written their roll number. Good. So from that I have taken. Okay. Pawan go away.
Yes, sir.
तुम्ही लेक्चर अटेंड करताय का आज दिसतंय मला का करताय
नाही सर आहे अटेंड अटेंड
बरं
करतो.
ओके 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 71 का ओके and 1 more. Again, this is a abrasive water jet cutting. See, in growing is there on that spherical shaped surface. If you don't understand during this Google Meet lecture, you can watch that YouTube lectures also. No problem. Same parts I have covered there. Okay. Repeatedly you can see. No problem. So tomorrow morning you will get lecture on this. Whatever I have taught today, no, on that you will get tomorrow morning new lecture. Already that overview means the total entire part of this topic, ultrasonic machining, I have covered yesterday and today. Okay, yesterday's 10 11 minutes and today's 12 minutes. Okay. See how that cutting happening using that water abrasive water jet with a high velocity. Please try to take some project ideas from our subject and you can go for manufacturing or the development of any type of this advanced machining processes. But for the micro machining purpose, you can go for that. See, this is a finished component. One more I want. अल्ट्रासोनिक मशीन ज्यांचं मिस झालं सॉरी अब्रेसिव्ह वॉटर जेट कटिंग ज्यांचं मिस झालं त्यांच्यासाठी हे 2 मिनिटाचा एक व्हिडिओ यू कॅन सी at top I have given the pressurized water, then at bottom workpiece is there, in between that workpiece is there. Okay, then there is a port to give the abrasives. Okay, that is the pointer where I have to know that abrasive, then water, high pressure water, the mixing takes place. Okay, and through that nozzle you can hit or impinge or strike the high velocity abrasive water jet on the workpiece. They have mentioned slurry because that mixing. Okay. Understood? Now this remaining part of this our ultrasonic machining, that means the setup and process parameter application, we'll discuss in next lecture, because one lecture is required to finish this remaining part, and then we'll start the chapter number 3. Okay, so I hope everybody understood what I taught today, okay, with the videos. Understood? Understood?
Yes, sir.
Okay, so shall we stop here?